Okay. Every lesson I start with okay. So that was my obligatory okay. Today we're going to be writing piecewise functions. Yesterday we graphed them. Today we're going to write them. So we know how to go in the reverse order. Thank you. Yeah, that's what that looked like. Okay, so we see we have this piecewise function that it consists of two pieces of line segments. Well, a line segment and array. So this one exists from here to here. So when I'm writing them, I like to work from left to right. So I'll deal with this piece of this function first. On this one, it is restricted over this interval from -3 to 0. It includes the -3. It doesn't include the 0. That appears to be an open circle, which it would have to be, or it would not be a function. Okay, so I dealt with the restriction first. And now let's take a look at this. What is this function?
Y equals 2.
It's y equals 2. It's a line. So here's my y equals part, guys. F of x equals 2. If, and there's your restriction on the domain. Now, I could write the restriction on the domain as an inequality also. It would just look like this. -3 is less than or equal to x is less than 0. And you can do either. I like interval notation because it's shorter.
It's easier.
Yeah.
I like the other one.
Okay. Either way. All right. Now this one. This part starts here and goes forever. So the restriction on the domain would be from 0 to infinity. Or you could write x is greater than or equal to 0. Either way. Now let's go back and describe that function. What equation would model that function?
1/2 x minus 2.
Okay, so the slope is 1/2 and the y-intercept is -2. Great. 1/2 x minus 2. We're done.
Oh.
Is that how we're doing it?
We're going to do these 4, and then I'm going to give you time to start working on the back. You can finish it tomorrow along with the worksheet you get tomorrow on absolute value functions. Okay, so this one seems to kind of split right here. We have a function on this side that goes on forever, and we have a function on that side that goes in to get forever. So these two pieces form the piecewise function. It almost looks like an absolute value function, which is what we'll talk about tomorrow. But the slope on this side is +2, and the slope on that side is -1, so it's close, but not quite. So let's start with the easiest part, the restriction. This one goes from -1, x values that are less than or equal to -1, which would be as an interval from -infinity to -1. Now, do you see how I have contained the -1 within this domain? So since I chose to put the -1 with this one, I would not include it with the other. And you get to pick. So the second function I could write as -1 to +infinity. Or x is greater than -1. So since I chose the equal to in the first one, the second one does not have it. And it could have gone either way. This could not include and this one include. Okay, so once again we have a ray, so I would model that with a linear function. What's the slope of the left side? 2. Now, what is the y-intercept? If we went up, yep, it should be 3. So you can either extend to find the y-intercept, or you could pick a point and plug it into y equals mx plus b and find b. Or point slope form, for that matter. Okay, what's the equation for the second line? -x. So far, so good? Okay, so now let's mix it up a little bit, add some more. Let's do a U try right here. Let's do a U try here, and then we'll do this one together. It has 3, correct. So you're going to have 3 equations this
Yeah, I'm
time.
not
Which is
looking
just
at it.
horrible.
You can do this.
I already did it.
I think I put the second point right here, guys, so if you can't see it, that's your second point on that one.
Oh, there's a point.
So it doesn't continue.
I mean, it does continue, but if you couldn't tell where it crossed nicely, that's where it is. Okay, if you think you have it, check, see how I did.
I got 2 for the y-intercept.
Yeah, I got
for the
yeah,
last
me
one.
too for the
I
last
got
one. For the blue
2.
one.
Really,
Y-intercept for the
JC?
last
Good
one.
one.
I got that here.
I think 2 is correct.
Wow.
Nice job.
At least Mr. Leonard wasn't into this third one.
Thanks, Jake.
That was straight.
Appreciate you rooting for me.
Some of these graphs are hard to tell, like, what lines they're going to check.
Okay, now I kind of like the last one because it's got the good stuff in it.
I disagree.
You just have to figure out what the good stuff is. Okay, so looks like we have 3 distinct pieces. All right, this one is what?
Negative x.
What kind of function?
Quadratic.
Quadratic. Quadratic. This is what? Linear. And this is what? Square root. Okay, so a quadratic, and I can tell that this is the vertex because I went over 1, down 1. So what is the equation for that quadratic? Negative
Negative x squared. Negative
x
Square.
minus,
squared. Where's the vertex, guys?
2.
Plus 2.
And then plus 1.
Plus 1. Negative x plus 2 squared plus 1. Does that make sense to everyone now? Because we had to shift it over to the vertex. It's opening down, and the moves are not doubled. They're just regular moves. So if the restriction on the domain would be from negative infinity to what is the x value right here? Negative 2. Do you want to include it or not include it?
Include it.
Include it. Okay, so we included here. So for our next piece of this piecewise function, we may not include that point because we just included it there. What is the equation that represents the next piece? 1. If, what is the interval for this one?
I can do both.
Negative 2 to 1. Would you like to include or not include the 1?
Not include.
You were
Include.
outranked. Not outranked, but anyway. Too many other people voted otherwise. All right, what's the equation for this square root? Square root of x minus 1
Plus 1.
plus 1
Yeah.
if
Oh.
Or equal to.
Like bracket
Or
1,
equal
2,
to
and
1.
Okay, did we really need to put a restriction on that domain? We didn't, did we? What is the regular domain of this function? 1 to infinity. So we didn't really restrict the domain at all. That is the domain. Interesting.
First,
This is
interval
fun, I love
notation
it.
versus equality.
Okay,
Stacey, you're not the boss, right?
you know what? I think you guys actually have time today
No,
to go ahead and turn that over and finish it.
Yeah.
So what are we gonna do tomorrow?
Tomorrow, I have a worksheet that's front and back. The front is absolute value problems. The back is kind of putting it all together, starting your review.
This will be first use interval notation or inequalities for expressing what.
I like interval notation better, but if you were ever in a standardized testing situation, they're going to use inequality notation.
Why do they use inequality? That's just like, it's just more confusing.
Well, up until middle school, all the way through middle school, you had never seen inequality. And there are probably schools that, you've never seen interval notation. And unless you're really on the track to go to higher level mathematics, it's not critical. We just introduced it early, so because you guys are headed to calculus. We just want you ready. We want you ready.